Greetings. This diagram is set up to illustrate why it is that the number of numbers between 0 and 1 is just as big or small, whatever way you want to look at it, as the number of numbers from 0 to infinity. Put another way, numbers represent or can be used to represent information, so the amount of information between 0 and 1 is just as rich as the amount of information between 0 and infinity. If we draw a line from 1 on the y-axis to slice through the parabola y equals x squared at this point here, and continue that extension of the line down to the x-axis, it meets it here. So the corresponding value of x at the point of intersection there can be thought of as mapping to a point over here. And it's a unique mapping. There is only one such point. Similarly, if we take this line, extend it down to the x-axis, the point just here of intersection has an x value slightly to the left of the previous one, and it maps uniquely to a point over here. Now let's look at this case where we draw our line from 1 on the y-axis down to 1 on the x-axis. This point here is the point of intersection of the parabola and the line, and it has an x value there. This x value maps uniquely to 1 on the x-axis. Going back the other way, we draw a line from 1 down to the x-axis. The point of intersection has an x value here. It maps to there. So they're getting closer here. What happens at this top end up here? As these lines get closer and closer to the hole at 1, 1, the lines become longer. The points of intersection between the parabola and the line have x values extremely close to 1. So those points, which all bunch up round 1, have x values, corresponding x values, that go off to infinity. Of course, if the line passed through the hole, we would be looking at a line parallel to the x-axis itself. And in a sense, if we think of two parallel lines as meeting at infinity, then the hole will map to infinity itself. Now what's intriguing about this diagram is just the scale of things. We could have thought of this as the point instead of 1, 1 as 0.0001, and the same here. Well, there'd be a corresponding value, of course. We could adjust the scale of this parabola so that that point was still had the same x and the same y value. So in effect, we could redraw our diagram so that the number here on this axis was as small as we please, diminishingly small. For example, this small. The corresponding y value we would choose to be the same, and we would adjust the dilation term out the front here to make it all happen. And then by drawing in the same sort of geometric structures, we would find that every point between 0 and this new one here mapped to a point uniquely between 0 and infinity. This rather astonishing result can be encapsulated in the simple summary that all the numbers in an infinitely small or an interval of infinitely small length of our choosing can be mapped uniquely to a line of infinitely large length. So there's just as much information in an infinitely small interval as there is in an infinitely large one. Now this astonishing result seems to have parallels too in the contemporary rendition of the universe, where the entire universe is effectively created from nothing. There is just as much information in nothing as there is in the entire universe itself. An interesting parallel worthy of further reflection. Well, thank you for your attention, and hopefully you will have further questions. Thank you.